Okay, hello. Nice to see you here. Thank you for being at my session. Thank you for choosing it between the other ones. And thank you, organizers, for getting me for this conference. It's my first time in Bucharest, actually, so it's even more exciting for me. So, I have several HoloLens and mixed reality talks, and organizers choose to ask me to do one of them, which is not the very basic and introductory one and not the live coding one, but the one where I do a little bit of introduction and then focus on more on one particular, in my opinion, most exciting feature of HoloLens, which is spatial mapping. And that's what we're going to focus today. But let me first, before we continue with the technology, let's first introduce myself. I'm Rafał Legiędź. I come from Poland. You can find me on Twitter at Rafek. And I'm a software engineer. I work for a company called SolidBrain. And for last year, I'm mainly focused on mixed reality, augmented reality, HoloLens, and I'm exploring the technology. I'm talking with different businesses, creating different proof of concepts for different industries to see how it fits, how possibilities of this platform can solve different problems across many industries. And there's a lot of interest in it, actually. Also, I'm a conference organizer. I organize a conference in Krakow, Poland, called DevConf. We're doing it since 2011, so it's 8 years now. It's in September, so if you'd like to come, it's devconf.pl. The tickets are on sale already. And also, I try to be a conference speaker, so whenever I think I have something interesting to say, I apply to conferences, and for example, hence I'm here. And I talked so much about HoloLenses for the last year that Microsoft, because that's Microsoft's device, HoloLenses, they decided to give me MVP because I was loud about this subject, and they're giving awards for that. So yeah, as of February the 1st, I'm a Microsoft MVP for HoloLenses. Okay, so that's enough about me. Let's first, at the beginning, let's talk about those abbreviations that are very common nowadays. And I want to make sure that we're on the same page, that everyone understands what VR and AR is, that there is an understanding around this topic. So, VR stands for virtual reality, which is, well, the experience that you can get with kind of an occluded device. It might be a device like Oculus Rift or HTC Vive, or a mobile phone that you put into a headset and you're totally immersed into some kind of artificial environment. So I don't know how many of you have tried HTC Vive, Oculus Rift, or any kind of mobile VR thing. Not many of you. So those who already tried already know that, but those who didn't probably don't know that VR kind of moved the person using it into totally different environment, so that actually the mind is being tricked into thinking that the real world doesn't exist, that everything that is real is actually this artificial synthetic environment that is created by the application within that headset. And we are immune for like external signals that come to our body because we think we are in a different world. Which is fine for entertainment industry, for example, and in some other cases. And on the other hand, we have augmented reality, which is what abbreviation AR stands for. And this is the most common way AR is available right now is on our mobile devices, like mobile phones or tablets, where the AR application being run on the device uses the camera lenses and whatever the camera lenses see is being displayed on the screen, and then on top of that picture, some other digital content is being rendered, right? I mean, the best example of augmented reality application is Pokemon Go. This is the most common one, right? I mean, that's why AR term became so common and popular, actually, and everyone knows what Pokemon Go is. And there are some other devices, AR devices, that come in the form of glasses or goggles, and there are all sorts of them, from the very simple one to very advanced one. And HoloLenses is one of them, actually, the head-mounted display, which is very advanced, and this is what the topic is all about. And you might also see on the internet or different articles or how Microsoft is referring to it, that there is also a third term, which is called MR, which stands for mixed reality. And there's lots of confusion around it. I mean, at least it used to be, because we had like AR, VR, and MR. So what's MR then, right? So this picture put it clear that mixed reality is basically the whole spectrum of experiences between physical reality and digital reality. So depending on device that we are using or the software that is running on this device, we can get different experiences, I would say. We can have some mixtures of augmented reality and virtual reality. And I'm not going to go here into details, but there is a whole spectrum of those experiences. And most of augmented reality experiences are very near physical reality because users are usually fully aware that they are still in the physical reality, because whenever we are using augmented reality on our phones, we still like perfectly know that we are here and we only see only a small fraction of our real world augmented with digital stuff. On the other hand, all the virtual reality stuff is on the other hand, where we are basically in a fully digital world. Sometimes we know where is the floor in those more advanced headsets like HTC Vive or Oculus Rift. But yeah, those devices, those experiences lives on those two extremes. And mixed reality is the whole spectrum. So augmented reality is mixed reality and virtual reality is mixed reality, right? So I think the confusion disappears here. And we have HoloLenses. How many of you have seen this device or heard about it? Okay, so like half of you, which is good. And what I want to say is that this device is not very new. It's by Microsoft. Microsoft is a vendor of this device. It runs Windows 10, so it's nothing like anything special embedded operational system there, but it's like regular PC with Windows 10. And it was announced in 2015, so it's 3 years now until it was announced. And it was released in mid-2016. The first wave of devices was sent to developers in June 2016. So it's almost 2 years that it's out there. And actually many companies started developing for this platform, and many businesses started to leverage this kind of technology and enhancing their processes and their businesses with it. What else I can say about this? This is the device that doesn't occlude our vision, so we put it in our head and we actually see whatever is around us because the display is transparent. And we have some special screens there so that they display additional stuff in front of our eyes. Also, as I mentioned, it's a regular PC. So we do not need any connection to any external computer or a unit that gives us computing power. We can, if we would like some extra power for our device, but it's not necessary, and most of the experiences doesn't actually use it. And also, so it's untethered, it's Windows 10, and it costs, for the developer kit, it costs 3,000 euros. So it's not very cheap. It's 5K for a commercial version. But the main thing is that it's not consumer-targeted device. It's mainly for businesses. So this price can't be compared to I don't know, mobile phones, for example, right? And that's where all most of the clients are right now. Those clients are usually big companies or smaller ones that can afford that. So after we put this device in our hand, we can fire up the application, regular Windows 10 application, and then we can have all sorts of stuff in front of our eyes. I mean, I'm not going to show you how to code for it during this session, but basically we're coding here in Unity or DirectX. So we're using Unity and C# or C++ and DirectX. And if you're familiar with this technology, or at least you know what it stands for, those are basically the game engines that are behind many titles, gaming titles nowadays. So you can imagine here that whatever we can do in those 3D engines can be done here. So we can basically visualize anything in front of our eyes. Well, given what kind of constraint we have with this device. But well, there's no limits what you can do, how we can augment the world. So how is this even possible? So this is a pretty sophisticated piece of engineering. That's why probably it costs so much. So it wouldn't be all possible without all kind of sensors that are mounted here. So long story short, it could be said that it's an enhanced Kinect being mounted on your forehead, because that's partly true. It's some next iteration of Kinect, but it has something more. So on the sides, they have HoloLens has 4 environmental understanding cameras, which are for those things, which are for scanning the environment, and this is what is this session all about. So I'm going to elaborate on that a little bit later. But basically, those cameras work in a way that they detect where are the surfaces around the user, and they build internal model of the location of the user, so that developer can use it within an application. It also has microphones, it has RGB camera, it has depth sensor, it has ambient light sensor, it has mixed reality capture sensor, which is for streaming whatever the user see into the computer, so that someone else can see what the user sees. And I will show you that feature. And well, that's pretty much it for the sensors. The other thing is that makes it all possible are those optical lenses. I'm not going to go here into very details. Those are 2 waveguides powered by 2 HD engines. So we have 720p per eye, and they can render holograms in front of our eyes, I mean 3D objects, and they can so that the user can feel if the object is nearer to the user or further, etc. The disadvantage of this technology is that it doesn't allow for a big field of view. So it's not like 110 degrees field of view. It's rather something around 40 degrees. So as we can see everything around us, because it's not opaque, we can see holograms rendered only in kind of a frame in front of the user. So that's a little disadvantage, but that probably will change in the future. And this is the disadvantage because of the technology that is used for the lenses. And last but not least, there's a special processing unit which is called HPU, Holographic Processing Unit. And this unit is for processing all the sensory inputs. So whatever comes from the sensors is being processed by this unit and then passed to the other CPU, the main CPU of the device. For the other hardware, inside it has regular CPU, but 32-bit, not 64. It has 2 gigs of RAM. It has 60 gigs of flash storage. It has Bluetooth, Wi-Fi, and batteries, of course, and they allow for up to 3 hours of active use. So that's pretty much it as it comes for the device itself. So how do we use it? How do we, well, we put it in our head. We don't have keyboard. We don't have any mouse. So how do we issue commands to this device, right? So there is this GGV input paradigm, which stands for gaze, gesture, and voice. So gaze, it's very similar to what we have in VR headsets. So basically, we can imagine a laser that comes from our forehead, and wherever it hits something, it leaves a dot. That's our cursor. So we can see a cursor in front of our eyes, and it moves with our head movement. So we have a dot that comes with our head movement, not eyes movement, head movement. This is very important. So that's why whenever you see a person using HoloLenses, they usually just move their head a lot. So that might change because pupil tracking is really a hot topic right now. So it might be integrated maybe in some near future. So whenever we look at something, we can issue command to operate on some objects, well, depending on the application we're using, of course. So it's usually a combination of pointing something with our gaze and then issuing command. And we can issue commands with gestures and voice. And we have basically one gesture available for the user and for the developers out of the box, which is an air tap gesture, which is like this. So we look at something and we just issue this kind of gesture. That's as simple as that. We also have a system gesture, which is called Bloom, which is like this. And this is for opening start menu or closing the application or closing the start menu. So this is a system gesture. We can't use it within our application. I mean, we can't program it. We can use it in our application to close it, but we have only this gesture. But based on this gesture, we have some other gestures derived, like hold, which is like half of the air tap, and navigation or manipulation, which is hold, and then movement, so that we can track the hand movement and, for example, resize things or move things around. So, and there is a voice command support, so we can program against it, and we can also have the functionality so that we can look at something and then say something, and then something will happen. The only supported language is English right now, so it might be a downside, maybe not, but it works really, really well. And as I mentioned before, it has 4 microphones mounted here, and there are all like directional microphones, and the device, it makes sure that the command actually comes from user's mouth and not the person like standing next to the user. So it works really, really well. So to give you some examples and to give you idea and to prove that it actually is a piece of technology that is being used out there. It's not like some science fiction thing and some kind of prototype. There are actually some real use cases for it. And I'm just only showing you here like 4 most popular ones, but if you would Google HoloLens plus, I don't know, any name of the industry, like HoloLens manufacturing, HoloLens healthcare, HoloLens construction, engineering, whatever, automotive, whatever, you will find lots of different use cases and real applications that actually are being used out there by the companies. I mean, big companies like Volvo, BMW, or GE, or Schneider Electric, for example. So it's a real thing. It's happening. It's a really good time actually to put your hands on this kind of technology. I mean, AR in general. So let's just go through these cases. So the first one on the left top is Citibank. They created a trading application for their workers, trading workers. So it's a AR application for banking, right? So, I mean, you might thought that you wouldn't be able to fit AR into banking, but well, you can. So you can extend the desktop of the user actually to not to be limited to regular screens, but you can basically render whatever 3D objects you might want to, right? So we can visualize all the data that are flowing in, and you can give user the possibility to operate on this data, like bringing stuff here and there and click through some graphs, etc. And in this case, there is also a sharing scenario, so that there is another person working on the similar application on his computer, and he actually sees whatever this guy is doing to the data. So there are a lot of different possibilities unlocked here. The other one is by Ford. They recently announced that they're working on the HoloLens application for the designing process, so that they can review designs of their new cars with HoloLenses, which is also pretty cool, so because you can visualize the new concept with your 3D glasses instead of looking at the monitor, right? And here is also shown the scenario that 2 guys are wearing HoloLenses, and it's one of the cool features as well about HoloLenses, and I have like a all separate session about it, multi-user scenarios, because with HoloLenses we can run the same instance of the application on several headsets, like up to, I don't know, maybe 20 or something, or even more. And we can connect them as we are connecting in multiplayer games, because that's basically the same mechanism. And we can align whatever the one user sees with whatever the other user sees, and they can basically see the very same thing and operate on the very same thing. So they can look at the very same set of holograms, which is pretty cool, because that unlocks lots of different collaborative scenarios as well in this case. The other one, Schneider Electric, is one of my favorite. It's actually application for service workers that they do maintenance work on some kind of pieces of machinery by Schneider Electric. And this application basically overlays steps to perform on the physical machine. So the user approaches the machine, and all of a sudden, I mean, when he or she fired the application, he will see steps overlaid on that machine, like unscrew this bolt, or open this, or use this wrench to unscrew something. And step by step, you can basically lead the user to perform tasks. And well, you can clearly see the benefit here, actually, right? The other one is ThyssenKrupp, the company that does elevators, and they also have this application. This is the most common one, I think. I mean, the most popular one. They did a pretty good job with that. Also, the application for service worker, so that whenever the guy is maintaining a elevator, he or she can have all the contextual information in front of the eyes, so that he can have like manuals, video manuals, or like set of tools that he or she needs, or the 3D model of the thing that he's going to operate on, etc., etc. I mean, we can have anything there. Whatever we can render can be there. Okay. And as I said, you can find lots of different scenarios out there. So just out of curiosity, Google for them, and you will see. For every each of them that I've shown here, there are actually YouTube videos, so that there is the good, so that you can get a good understanding how it all works. But coming into the thing that we are going to talk here about, spatial mapping, and the environmental understanding cameras that are here, there are some other scenarios unlocked for HoloLenses. Basically, the HoloLenses can scan the user environment, and developers can put the data into use, so that we can detect within application where is the floor, where are walls, where are chairs, etc. I mean, we can't scan out of the box like really precisely, so we can't, for example, detect if the bottle is here or not. We will get like a rough shape maybe, but we can detect overall feeling of the location. And based on that, there are 3 good applications that were created at the very beginning, when the HoloLenses were released, that they show how you can use those spatial data in your application into a really good extent. So, for example, there's Young Conquer game where you have this red guy running on your floor, jumping on your table, and shooting to other targets that are running in your room. There is a game called Fragments. That's my favorite one. Actually, your room is being transformed into a crime scene, and you look for clues. You're trying to solve a crime. There are clues hidden in your room, and there are holographic people walking around and sitting on your sofa, for example, which is pretty amazing, immersive game, and you have to try it if you have time. You have to try this game. It takes time, but it's really cool. And the other one, Roborate, it's very cool as well. There's an alien invasion, so that aliens are attacking you, and they drill through your walls. So you see like things coming out from your walls, and then some aliens come out from there, and you just shoot them. And if you miss-shoot them, you will make like holes in your wall. The experience there is also pretty cool. I have this game. Anyone who would like to try it, you can try it after the session. So this is all possible because of spatial mapping capabilities and those wonderful cameras, and because of this holographic processing unit. So this is the thing called spatial mapping. So from the moment that the device is turned on, and we can't stop it, from the moment when it's turned on, it starts scanning. I mean, whether there's an application running or not, it scans all the time. So if I would turn it on right now, turn it on, I don't have to fire any other application. It's just Windows 10 running right now, and it scans. It just grabs the information, whatever it sees. I mean, up to 3 meters, and whatever there is, he grabs it. I mean, it grabs it. It doesn't take pictures. It just detects where are the surfaces, so that it can build up the model. It uses different combination of things, I guess. I mean, colors, maybe some special features of the surfaces to build up the model and to know what the device is looking at. But yeah, basically it scans the area of the user all the time, and it stores all the data within operational system. So the common misconception here is if we have to handle spatial mapping, like grabbing the data within our application. I mean, no, we don't have to. It's happening by itself by the device. We can use those data later, but all the grabbing of data is being done by the operational system. So, for example, right now it's running, it's grabbing data in this room. And it probably created like a separate bucket within the system on our hard drive, which is called space. And it puts all the data that it grabs right now into this space, right? And that's it. It just saves it there. We can see in Windows 10, we can go to settings and spaces. We can see what spaces the device knows about. But we don't have much information there. We only can see like space 4, space 3, space 1, whatever that means, and how big is this bucket, I would say. So not many informations here available. And actually we can't view from this point how those data look like. It's some kind of a black box, so we can't see, well, I can't go there and see how much data of my apartment is there right now on this device. I just can't. But as a developers, and well, maybe not as a developers, there's one feature on HoloLenses that allows us to view current location. So if I would connect to HoloLens right now, and I will do it in a second, I can display whatever the currently scanned environment looks like. So let me do this so that you will get an understanding what I'm talking about. I hope it works. Let me check the connection. Okay, I just need to connect to my hotspot. Sorry for that, because it disconnected. Because I need to, what I'm doing right now, to connect to HoloLens, I need to be on the same network, and I just put IP address of HoloLenses into a web browser, and then something which is called device portal will pop out, and I can see stuff there, which I will present in a second. I just need to connect to my hotspot. Come on. Okay. Okay, it should work now. Okay. So we go here. Here, okay, so this is this device portal thing. We have all sorts of features here, like we can see statistics, we can upload applications, but what I'm going to show you right now is 3D View tab, where we have this, this model. So, we can see whatever the device already know about this location. Let me zoom it. You can see my head position here. Whoops. Okay. Okay, so I'm standing here. I'm looking. Whoa, 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 whoa! I don't want that. You can see I'm looking to my left, and then I'm looking straight, and I can just walk around so that it will grab more and more information. See? So that's the model I have in my device, and I can make use of it within my application. What's more, I can actually even export it here. I can save it, and it will be exported into regular 3D object, like a regular one, so that I can import it in my Unity project and just use it, so that I can simulate my application without the headset, but in Unity project, so that I don't have to deploy the application all over to my device. So that's how it looks like. What happened again? Okay, but that you have an idea how it looks like, so that's what I wanted to show you. So where is that cursor? Okay. Okay. How much time do we have? Okay, like 25 minutes. Okay, so this is the data that is gathered on our device, and how to put it into use. So how, as a developers, can we access those data and what we can do with it, how hard it is or how easy it is, or what's the overall workflow of using those data. So within Unity, because well, most of the people, most of the community, they just use Unity for HoloLens development. So we have in Unity API, scripting API, we have spatial mapping classes, and we can use objects from there for accessing spatial mapping data. So the main object, main class there is called Surface Observer, and that's basically we need to have at least one for our application, so that we have an entity that observes any changes in the environment. And by this I mean it observes whatever is being stored in that internal spaces bucket, so that the gathering of the data is being done by operational system, and then our application looks into those buckets, and the changes that come to our application came from those buckets. We do not directly access the sensor and scan our environment. So we create Surface Observer, and then based on that, we define a spatial volume. So we define the area around the user within which we are interested in updates. So for example, to give you an example, the HoloLens, they scan the environment all the time, and they can see up to 3 meters. So we can scan this whole room, for example, and we can have the model of this room. But for our application, we might define that we only need to get updates from our operational system from like 2 meters around the user, right? So we can define like body-locked box spatial volume, so that would be something like invisible box around the user 2 meters by 2 meters, for example, or 3 meters by 3 meters, and we would be getting all the updates only within that box. And we can create like spheres or frustum-based spatial volumes. So it all depends on the scenario. So for example, for a standing scenario, so that we do not require for a user to go a lot with our application being run, we can define word-locked box spatial volume, big one, for example, like 5 meters by 5 meters, so that we are only interested in those information in this box. So we won't be getting any updates from anything that is happening outside of this box. And that would be for like a very stationary scenario. And on the other hand, we can have a scenario where we require the user to walk a lot, like the warehouse application, where the user would go from one alley to the other alley, so that we would probably want to get updates from a frustum that is in front of the user, so that it's this field of view thing, so that we will only get updates from there. So whenever the user looks and goes, we will get updates from there. So it all depends on the scenario. And it can be body locked there. So this frustum would be body locked to user's head, and we will get updates from there. And based on that, we can register for surface changes, and we just wait for updates. And whenever we get an update about the surface that was detected, or it was detected that the surface was deleted, we can define what we're doing with that. So we process the surface changes. So if the surface is added, we can render the surface or do something with those data. Update it, we can update it, delete it, we can cache it, or just delete it. And then we can access, we can request the mesh of this data. And I will visualize that in a second. But based on this data that we got from this surface observer, we can decide what we're doing with it. And we can literally request for a mesh. So if we got a piece of surface from our surface observer, a piece of our wall, we can say, okay, give me the mesh for that, so that I can visualize it for the user. And I can also decide if I would like to have a collider with it, which I'll explain that in a second. And then I can render it or not. So after this whole process, and this is usually the ongoing process, I mean, depending on the scenario, but usually it just scans and builds the environment all the time. We can stop it, but that's not what I'm going to talk about right now. Based on that, we might get this. I know that doesn't say much, but if you think about it, it's a mesh of the room. It's a model of the room, right? I don't know if you can see it from this perspective, but it's a room. So after some time, when the device has enough information about the environment, we can request all the meshes of surfaces around the user, and we can literally build the whole room within our application. And this is not exciting because, well, I can display it, and I could build this simple application for this room, and whatever I would see, well, black would be transparent on HoloLens, so I would see the actual physical thing instead of black here. So this, if I would run in this room, I would basically see this white mesh whenever the real surface is. So I would have this white mesh aligned with the surfaces. Usually don't do that because it's it's not useful, right? It's only for visualization of what we detected. But what's super important here is that with those meshes, we also might get colliders. And colliders are the mechanism in our 3D programming engine, 3D engine. That colliders are those entities that unlocks all the physical interactions for us. So whatever 3D object we render and we assign a collider to it, and we would have another collider somewhere else on some other 3D object, which is, for example, our room model, we can do all the interactions. So you can imagine if we would have all the colliders whenever we have real surfaces like floor and a nicely aligned collider with the floor, we can basically drop a virtual ball in our application onto the floor, and this ball will actually bounce on the floor or just stays there, right? So that unlocks the scenario where we can literally blend physical world with the virtual world within our applications, right? I will show pictures for that. So don't worry. It's not perfect. There are a lot of errors during the scanning process, so it's not like we can scan everything and everything will be perfect, no holes, perfectly aligned surfaces. It all depends on the environment. So we have to be sure we're doing a lot of post-processing of the mesh if we want to make sure it's pretty good, or we have to make sure that we have a good environment for scanning. So the most common affecting factors for scanning, for a room scanning, are user motion. So for example, if I would like fire up the HoloLens and would just walk around here real quick, obviously I wouldn't grab every possible data here, right? I would have some regions which wouldn't be scanned properly. Also, surface materials. It's good when surfaces have some kind of patterns on them. If we would go into like completely white room, like completely everything would be white, right? Floor, ceilings, and walls. The device wouldn't have any particular feature to start attaching attention, I would say, right? And start grabbing information based on that point. So surface materials are also very important. And scene motion. So, well, if we would have a lot of moving things around the user, it would affect all the scanned data. So if we have person in front of, if I would have a person in front of me, when I would be scanning the environment, I would scan this person. And if that person would move a little bit, I would have the model of the shape of this person in front of me, and then it would disappear after a while, and it would appear where that person will stay. So if I would have like lots of this kind of moving objects, I would have lots of, we call it hallucinations around us. So we have to deal with that in our post-processing scenarios. And then also lightning interference. If it's too light or too dark, we have lots of different errors, and the surfaces aren't scanned properly, especially when it's dark. So we have to then come closer to the area to scan it better, or just put some more light into it. And based on that, we have some errors. And also, well, there's one other thing, mirrors. Mirrors are tricky because when we are looking in the mirror, actually HoloLens thinks that there's another room there, and it creates a model of our room behind the mirror, which is pretty fun. Errors that are derived from those affecting factors are holes. So if we don't grab every possible surface in our environment, we can have holes, and that may end up in the thing that, imagine we have a mesh of our room and we have one spot on our floor which is unscanned, and there's a hole there. this virtual hole, and we have our virtual objects that we play with in our application, and it would be dropped where that hole is. So that basically that object would disappear into the void, right? So we have to make sure we don't have holes because we don't have colliders there as well. So we have to make sure we post-process those holes. Hallucinations, I already mentioned that. Those are the things that exist, that the spatial mesh exists of these things, but those things doesn't exist in physical world anymore. And also bias, if we don't look at the surface from different angles, but only from one angle, it happens that the physical surface is not aligned perfectly with whatever virtual representation of this surface we might have. So we might have a collider slightly above our floor, for example. So we have to make sure we work a lot with HoloLenses before we run some application. So to avoid all those errors, or at least most of them errors, there's usually a step in every application that uses spatial data, which is called like room scanning experience or anything like that. So even if the HoloLenses, I mean, the HoloLenses, they scan the environment all the time whenever they're turned on. But as developers, we are not sure where the user will be running the application. If the user will be running the application in a room that he or she already been to or not. So the application might be run in a completely fresh environment that the HoloLens isn't aware of, or in the environment that has been run like several times. So as developers, we have to make sure that the user actually will fire the application and will have some time to walk around and scan the environment to grab some data, whether we have those data or not, because we don't know that. So that's usually what is called room scanning experience, and you can see that in several applications. And that's usually something which is just visualized with some kind of a shader or animation on whatever surface is detected. So whenever we have a surface detected, we can just visualize it with some nice colors and stuff like that. So the user get an understanding of how much of the environment is actually scanned and if he or she can start working. And based on those data, we can do all sorts of cool stuff. I will show a quick demo in a second. There is this application available along with the library, which wraps some Unity API around spatial mapping. And there are some ready functions and methods and objects that we can use for different things, like room scanning. You can't see it properly here, but basically we can have some statistics about our scanned room displayed in front of our eyes. We can issue topology queries, so we can, based on this library, using this library, we can just ask the spatial mapping library, hey, give me like the largest wall, right? So we would get the reference as developers of the largest wall, and then we can, I don't know, just render something there, depending on the scenario. We can detect different shapes. So for example, we can detect like seatable areas or platforms so that we can place things there, depending on the scenario. And also there's a placement solver, which is pretty cool, so that we can issue, based on the spatial mapping data that we have, we can issue some queries. So for example, we can issue a query like, give me 3 boxes, 1 by 1 by 1, near me, on the floor. So it will run the query based on the data that it knows, and it will give you the coordinates of those shapes that it found. Of course, this is the sample application, so it visualizes what's possible, but we can use that in our application and just render regular things. So I wanted to show you that, and let's see. Okay, it seems it's connected. So I will again go to this device portal thing. Okay. Yeah, and I mentioned before that we have something which is called mixed reality capture sensor, which is something that allows for this. So you will see whatever I'm seeing, which is pretty cool, right? There's a slight delay here, like 2 or 3 seconds. So it's not like whatever I'm seeing right now you can see, but you can expect some delay. So this is the start menu of our Windows 10. We can fire the application. I will run basically this demo that I've just shown you. And by the way, I have the device with me. After the session, whoever is interested in trying it, you can just approach me during the break and you can try it. So I'm running the application. Hopefully it will run. It will scan this room. I mean, it will use the data that we know and it will gather some more. And then it will visualize whatever the surface we already know. And based on that, we will run all those queries that I've just mentioned. So you will probably start seeing a green grid. Can you see it? Because I can't see the screen. Is it visible there? Yeah, okay. So as you can see, it's being built up. And it somehow aligns with whatever we see. Sometimes it's good, sometimes it's worse. So you can see how accurate it is. But if you look closer, if I'm looking longer at some platform or shape, it will get better, right? So for example, here's the wall. I have to approach the wall when it's not light enough. And you can see it builds up. I know a lot already. So here what is implemented is that based on the data I processed, I can run some interpolation algorithm and fill all the void with some data that is interpolated based on what I know, right? So I can air tap here, and it will finalize the scan. And as you will see, it should build up the walls around me, because it just interpolated all the data. It assumed that there are some things where there's the wall where the hole is. So I have a virtual room around me right now. It's not perfect because I haven't scanned everything. And I can run queries here. For example, I can query for the largest wall. And you will see the largest wall that it found was here. So within my application, I could get the coordinates of this wall, and then I can do something with that. I can apply some texture, for example. I can detect C-table areas, and you will see that it will detect places that are good for sitting. So if we would have a virtual agent that we would program, and we would like to have and coordinates of the chair that this agent can sit on, we can show him, those are the coordinates, just sit here. And the game fragments that I already mentioned, it makes use of it pretty heavily, so that you actually have like a holographic person that goes into your room and sits on your sofa, for example, which is pretty amazing. Large empty surface, for example. Let's see what it will gives us. Oops. Oh yeah, so there is a large empty surface, for example. That's it. And also, whenever I'm looking at something with my cursor, I'm getting information if something is a wall or platform or floor. So those are all information that are being there, so we can make use of them. What else you can see? Object placement solver. That's pretty awesome. So we can detect on-floor objects which are near me, right? Those are some assumed parameters there. Those are all parameterized functions, so that we can do lots of things with that. But as you can see here, it found some spots near me of different sizes, right? So depending on the scenario, there's a game Smurfs, for example. It renders a Smurf village. So it renders some huts around the user, so that's, for example, the moment that you can make use of those kind of feature. On floor, let's see what it will find on the floor. So you can see it found me some spots for big objects on the floor, right? What else is interesting? On floor and ceiling, for example. So those are the columns, so that it finds the spots that connects an empty space on the floor and on the ceiling, so that we can have some columns, for example, right? And this is only the example. We can do all sorts of stuff here. so that you probably now get an idea of how it works. Okay, that's it, I guess, here. Let's continue with that. Okay, and yes, based on what I've just shown you, we can have all sorts of scenarios. So I will show you what can we do. For example, based on the spatial mapping that we have, we can create all the nav maps, navigation. So if we have some agents in our game or program, we can program how they walk around so that they do not hit those physical walls, or they do not walk in the air, but they walk on on physical things. We can have occlusion. So the virtual stuff occludes whatever physical stuff is, and vice versa. So for example, if this cap would drop behind this table would occlude it. So we would know that this cap is behind the table. This is pretty cool effect as well. Also, we have all physics. So as I described previously, so if we would have colliders everywhere, we can do all the physics interactions with that. So we can have, for example, balls that are hitting our walls or floors, for example. And placement. So we can just place things around. So as I've shown you with that application seconds ago, we can find spots and place things here and there, and so that we can feel that they are part of our environment, so that we can create those really, really immersive experiences for the user. And there's one cool feature with HoloLens as well, that we can point a place in space, and we can attach something which is called Spatial Anchor there, so that the HoloLens will put some extra work into tracking this point. And that means that if we would place a spatial anchor for this object, assuming that that's our application, we would like to user put this object here, and we would like this object to appear here on our next application run, so that the application kind of remember where this object is. We can attach a spatial anchor here, close the application, and fire up the application again, and the HoloLens, when they will identify that they are in this room, and they can do that in a pretty good way, they will find the spatial anchor, and they will place that hologram in the very same place, which is pretty awesome. So, well, yeah, based on all of this, as you saw, we can create all sorts of scenarios that are using the spatial mapping data, and that's the time for questions, if you have any. And if you would like to try HoloLens, I'm here, or I will be just outside, and you can try. Any questions? Okay, then, thank you then.